Thank you everyone for joining us today. And this is Cloud Islamabad webinar that we're hosting. And tonight we will be exploring how Snyk fit into the DevSecOps ecosystem. And we've seen the collaboration with the Docker. We have a CLI command that show the vulnerabilities of the images that you have baked into it. And tonight we're exploring some new of the features, and we're exploring how to build the pipeline that is already secure using Snyk. So that's a wonderful session for everyone interested to secure their containers. And I've seen the tweets of the Snyk. They're calling out, are your containers vulnerables? And the spoiler alerts, everybody containers are vulnerables. So tonight we focus on these terminologies, how we can secure our images, our containers, our applications, our dependencies, so we can build out the system that is from ground up, from developer machine to the staging to the production already secure using the pipeline. And that's a wonderful approach that the Snyk is using moving forward. And as of my guest is today is Matt Jarvis, and I think you already know a lot of his work on the KCD UK. He also manages the community works on the different cloud native user groups in UK, like Birmingham, and some of the other user groups, and also is a developer advocate at Snyk, and I think decades of experience in these kind of technologies. So I'm really proudful for having joined us today, and hopefully we'll learn a lot of great concepts about security, containers, Docker, and Snyk. Over to you, Matt, and you can share your screen and type your commands on the screen. Matt,
thank you.
Share your screen and type your commands on the screen.
Right, let's get this show on the road. Okay, so I'm going to talk a bit today about security around cloud native in general, and how we want to go about thinking about security for cloud native applications. And then hopefully we might get a chance at the end to actually show some of the features that I've talked about in Snyk at the end. So, but first of all, this is me. So I'm actually a director of developer advocacy at Snyk. I've been around open source for a pretty long time, as Saeem noted, and you can probably tell from the grey hair. But I've kind of worked on all sides of this equation. So I've been in development, I've been in operations, I've been in the DevOps world, and now in security. So the first thing that we really want to think about is about what's changed in terms of what the responsibility of developers is in the cloud era. So the story of kind of the last 10 years or so is that all these boundaries have become pretty blurred between what's an application, what's operations, and what constitutes infrastructure. The old view of the world was that the application was the only piece that developers were responsible for, and all these other elements of the stack sat under IT operations. And in this kind of model, security was usually a step right at the end of the deployment process. And the world we live in today is one where our infrastructure and our workloads, our applications, are pretty much completely tied together. Everything's declared as code, everything's a software development practice, and there's really very little difference between our workload, our application, and the computing infrastructure that goes along with it. And by infrastructure, we don't just mean the underlying compute technology. In most cases, we're talking about containers, but also the configuration and the operational policies that control those capabilities. And as a community of practitioners, we've discussed in lots of detail this kind of blurring and consuming of the boundary between development and operations. But in lots of cases, we haven't really considered how that impacts on how we model and practice security. In lots of organizations, security is still considered to be an external practice, something that exists only when our applications are deployed, when they're operational. But this is pretty unworkable when we start to think about things through lenses of continuous integration, continuous delivery. And as I said in the previous slide, developer-driven teams now have responsibilities for most of our deployment stack. And so this gives developers much greater responsibility for ensuring that these things are secure. By the time our code and our infrastructure is deployed to production, it's really too late to deal with security issues. We can't slow down that deployment velocity to introduce security gates in the way that things used to work. So that presents us with a set of kind of unique challenges. How do we make sure that our applications and our infrastructure are secure when our working practice is evolving into these super fast delivery pipelines? And security still matters a lot. I'm sure everybody's familiar with lots of the big breaches of companies that have happened over the last few years. And this can have a really big impact on companies, both from purely a financial perspective in terms of impact on their customers and customers leaving and potential fines, but also on how trusted our customers see us as. And trust's really one of the key metrics for successful businesses in the cloud era. So let's start by taking a look at the different classes of things we probably need to be looking at to make sure that we've considered security in our workflows. So firstly, the applications that we're creating. So these are our workloads. Modern applications are usually composed of a relatively small core of homegrown code, along with a lot of code from open source ecosystems, modules and packages that we've included in our code base. And this is great news for application development, because the availability of modules means we get to develop applications faster. We need to write less code, and we don't need to reinvent the wheel all the time by solving the same problems over and over again. And anyone who develops in Java, in Python, in Node, in Go is going to recognize this pattern. And in all of these ecosystems, the number of vulnerabilities is growing. And that isn't necessarily because code's getting more insecure. It could just be because there's more code being written. And we're getting better at working out what's vulnerable. But in the end, this all means there's more opportunities for these vulnerabilities to be exploited. And any piece of code that we include into our applications can have a very large dependency tree. So things can be direct dependencies, where we've specifically called them out in our code to say we want to include this package, this module. But those things are going to bring in what we call indirect dependencies. And that might potentially be a ton of other modules that you might not even be aware of. And typically something like nearly 80% of all security vulnerabilities are found in these indirect dependencies. And these are ones that we've got much less control over, and we might not even be aware of them at all. And as an example of that, here's an exploit from the Node community that was introduced into NPM in 2018. This is supposedly a library to parse HTTP headers, but it's actually a remote execution exploit. It's about 40 lines of code, processes JavaScript, and executes commands on the server using specially crafted HTTP requests. And this was hidden behind a tree of other dependencies until the direct dependency eventually ended up being used in Mail Parser, which has a huge amount of downloads every month. So it's pretty easy to see how in big developer communities, these kinds of indirect dependencies can be used to hide exploitable code. So that's the first bit, these vulnerabilities in our third-party dependencies, and they're super important because they make up such a large part of our code base these days. But as I said earlier, the lines between our application and the container it runs in are becoming increasingly blurred. The container is the delivery mechanism for the application. We'd probably never deploy the application without the container. They're typically developed at the same time, maybe by the same team. So for all intents and purposes, we can really consider them the same thing. And like that availability of library code, the huge growth in container registries has been great for the ability to run pre-packaged software super easily. But these are also a big source of vulnerabilities. When we look at the container landscape, best practices are emerging around things like multi-stage builds in Docker, building minimal containers, but there's still a huge amount of people who are using containers directly from the upstream repositories, upstream registries, and lots of these can have very significant amounts of vulnerabilities in them. And then there's also a kind of long tail. We can take the path of least resistance by giving applications containers based on full operating systems. And when we look at operating systems in general, the amount of vulnerabilities in base operating systems is massively growing, partly because operating systems by design ship with a lot of software in them. And, you know, in some ways, these kind of multi-purpose containers images we can sort of break the paradigms of why we use containers, in that we want something super minimal, but there's still a lot of people using these images for application deployments. And we can also see that people often don't think about emerging vulnerabilities once their workloads are in production. So an image that you used when you deployed that application might now have vulnerabilities in it, which hadn't been there when that image was built. And if you're not looking at container images you already have in production, then you're never going to find out if they're vulnerable. Fixing these things often isn't very hard. Over 40% of Docker image vulnerabilities can usually be fixed by upgrading the base image. And around 20% can be fixed just by rebuilding them, because a lot of containers will run an upgrade during the build process. So the next thing we want to look at, we've looked at our third-party code, we've looked at our container images. Now let's look at configuration. And now, as we've kind of moved wholesale into cloud and now into Kubernetes, configuration is almost entirely in code, and it's part of our development workflow. And by configuration, we can include all of our Kubernetes YAML, our Helm charts, our automation, our Terraform, and all the kind of policies and configuration that goes along with that. And this is a really massive growing field, as we can see from the amounts of this code that's in GitHub now. And we're really only just starting to view that as something we need to consider from a security perspective. Kubernetes is increasingly complex, and as we've moved the responsibilities for developing that kind of code into our development teams, there's clearly a lot of space for misunderstandings about how things work. And this is kind of compounded by things like service meshes, which increase complexity even further. And with that much code out there in the wild, we can again see the potential risks of taking the path of least resistance, where we might be using some existing code we found on GitHub as a template when we don't really properly understand how those things work. And these are all super important for the security of our environments. Almost all the big exploits that have happened recently are a combination of application level vulnerability together with infrastructure misconfiguration. And, you know, there's lots of examples I'm sure most folks are aware of, AWS cloud credential leakages, for example, or clusters being infested with crypto miners. So where do we start in terms of how we integrate these things that we want to look at into our workflows? And really what we want to do is to move our security practices over to the left, and we want to embed security into our development pipeline. So sort of share that burden of security across our development teams. And this is where the concept of DevSecOps comes into play, that we need to integrate security considerations into our workflows in exactly the same way that we merge development and operations over the last few years. And the obvious first place that we want to start is at the developer. So we need developers to have insights straight away into potential security issues, but these things need to be integrated into their workflow. So that means tooling that's available from your local command line, means integrations with your development environments. So we need to reduce the overhead for developers to use these tools right at the point they're working before code even gets into our repositories. And most importantly, the tooling that we use has to provide developers with the right information to be able to make security decisions. If we put together big lists of vulnerabilities, that's really not very useful. Most people outside of security professionals just don't have the time or the inclination to work out the how to deal with all these different vulnerabilities. So we need tools that give us insights into how severe vulnerabilities are and how exploitable they are, together with remediation advice, because what we really want to be doing is fixing things. We want to be giving people actionable ways forward to solve these problems. And we want to be doing those things across all of those areas that we talked about. So third-party open source code, container images, and your infrastructure code. So let's talk about the actual points in our workflow. So again, we've talked about developers in the developer environment, but the next stage is going to be your source code management. Our Git repository is now the single source of truth for everything, so that has to be secure. Git's been pretty secure over the years, and in most cases, folks are using hosted Git services like GitHub or GitLab, which have been pretty good at security, but there are definitely some process-related things to consider. Because of how Git works, it can open you up to certain issues, and our users need to be aware of these things. So we want to be enforcing two-factor authentication, making sure our users have strong key security practices and are keeping Git updated locally. Exposing private data is usually the biggest risk in source code, particularly in commit histories. So configuration data should really not be in Git unencrypted, even in local repositories, because it's so easy to then commit it in your history without noticing that you've done it. And it goes without saying that we need strong review processes. And this is really all about the human aspect of this. And we can enforce things here through automation as much as possible, things like pre-commit hooks. And once we're confident that Git is secure, we can start to leverage security scanning in our source code management. On every PR, we want to be looking for the same issues that we were catching at the local development stage. But this time, these are going to be automated, obviously. So scanning our code every time something changes in that repository. And we're also monitoring here for things that have changed upstream since a particular piece of code was committed. Even if our code hasn't changed, new vulnerabilities are discovered all the time, and code that didn't show vulnerabilities when that developer scanned it may now be vulnerable. So these monitoring scans over time on a regular basis will allow us to pick things up right in the code repository. And fixing things in source code management is a much easier place than trying to fix it in production. It's a lot cheaper to fix. And our container registries also fall into this category. Nothing's fixed in stone, so an image that looked fine when it was built could now be vulnerable. If your registry has built-in scanning, and many of them do, take advantage of it or use tools that integrate with your registry. If you're using Docker Hub, integrates automatically with Snyk, so you can scan your images with Snyk directly in Docker Hub. And another integration point is our CI/CD systems. And again, here we'll want to be looking at automated security scanning for container images, configuration, and for code. And because we're rebuilding our code here, we can catch things that might have changed since it was first scanned when it entered the source code repository. And then the final place we want to be looking is in our production environments. Containers in production, particularly if they don't change very often, can end up with vulnerable images. So we need to be looking both at running containers and as a double check at new containers being spawned. And in this space, we can also take advantage of admission controllers, things like Open Policy Agent, to ensure that our security policies are being reflected in code being deployed, so that our images are secure and we can actually stop things from hitting production automatically. So the takeaways from all that stuff is that we need to shift our security left and we need to empower developers to make decisions about security based on modern tooling, modern process. Security teams can't really be gatekeepers anymore with control over deployment. We need to consider the role of security professionals to be advisors and toolsmiths as opposed to gatekeepers. So allowing our development teams to get on with delivering new features and getting things to market. And visibility and remediation of security issues need to be baked into every stage of our development pipelines, leveraging automation to scan third-party code, container images, and our infrastructure code. So I think that's quite enough slides for now. I think we've probably got some time now to take a look at Snyk, and I can talk you through some of the features that we talked about there. So let's go and have a look at my where are we? Just bear with me 1 second. Let's move this. Okay, so this is my Snyk dashboard. Let me just move this over here. So what we're looking at here is the kind of high-level view of all the projects that I have in my configured in my Snyk. And so the first place you're going to start is to look at projects, and projects in Snyk are things that you've imported that you're going to scan for security issues. And we have integrations with a whole range of different source code management systems, different container registries, different CI/CD systems to make it super easy for you to bring in projects. So for example, if I go here, these are the integrations I have turned on. I can go add project from GitHub, and this is going to show me in my GitHub repository all these different projects that I can just import into Snyk by selecting them and then importing them. I'm not actually going to import anything there, but let's take a look at one of these projects that I've already imported from GitHub. I'll look at this one, I think. So we can see that when this project was imported, Snyk went and looked through that repository and discovered a whole load of artifacts that are interesting in the context of security scanning. So it's found the package.json, which defines the dependencies that this particular piece of software was pulling in. And it's identified in this package.json a whole bunch of vulnerabilities. This is a deliberately vulnerable application. So it's built an entire dependency tree, and we can see here that these are the top level ones here are the ones that were specifically defined in the package.json. But we can then drill down below those and see the indirect dependencies that were pulled in, the dependencies of the dependencies. And we can see in each one of these where the vulnerable packages are within that particular package. So if we look at one of these, we can see that we've got this high severity. And let's go back to here actually and look at one of these from this view. So if we look here, we've got this this vulnerability, this critical vulnerability in this package ADM zip, and we can see that Snyk has put a priority score on that. And this priority score is to help you as a developer be able to work out which things you should fix first. This priority score is not just based on the industry standard CVSS score, but it's also based on a number of other things that we do to enrich this data. So particularly, is there a mature exploit available in the wild for this particular vulnerability? And does it have a fix available? If a fix is available, it's kind of a no-brainer that for a severe vulnerability, you would just want to fix it. And one of the things that Snyk lets you do is to actually automate the fixing of these vulnerabilities. So if I click onto this, fix this vulnerability, I can actually raise a PR directly, excuse me, against my GitHub repository that's going to fix that automatically in my code without me needing to to do anything other than merge that PR. So that'll take a second to open that that PR in GitHub. But there we go. There's the PR in my source code system. It's telling me all the things I need to know about what that exploit is, and it's going to upgrade that package, I suspect. So it's going to take that package from 0.4.7 to 0.4.11, which is going to fix that vulnerability for me. And so these kinds of automated remediations are super important when you build security tools that are focused on developers, because what we really want to give developers is actionable insights, not just lists of things that are wrong, but ordered, prioritized lists of how you go about fixing things. Because you know, being able to fix things is ultimately the point, without necessarily having to go and look into each of these vulnerabilities and see what they are, what they do. And we can filter all these by all sorts of things. We can filter them by whether they're fixable, by priority score, by severity. And so we can drill down in all sorts of ways into this, into these things that are in the vulnerabilities that are in that particular package.json. And we can look at back at the top level again. We can see that we've also found some other things in this directory. We found a Docker file, and Snyk has actually tested the Docker file and looked at what vulnerabilities were in this particular Docker file. And so we can see that this base image that was used in this Docker file has a lot of vulnerabilities in it. But again, what Snyk has done is to suggest things, alternative base image types we could use to reduce our vulnerabilities. So this was built using the Node 6 stretch base image. And this has over 900 vulnerabilities in it now. It's pretty old. But if I was to swap to using Node Slim, this would reduce my vulnerability count to around 60. And again, I can open a fix PR directly against that Docker file, which will change that from line in the Docker file to use a different base image. And let's have a look what else we found in here. So we've got some Kubernetes manifests. So when we scan Kubernetes manifests, we look for a whole range of security settings to see whether those settings are in that deployment file or not. And we can see here that we've found a whole set of things varying from low to medium vulnerabilities in this YAML file. And if we dig down into one of these, we can see this is the containers running. This is running as this doesn't have the security context setting in this deployment to not allow you to run as root. So we can see here that it doesn't have security context run as non-root set. And it's also going to tell us what the impact of that is and how I can resolve it by setting run as non-root to true. And we can see there's a whole bunch of things that are similar within this file that Snyk's identified that we may want to address from a security perspective. You can also set to you could set the priority of these things in the Snyk configuration. So you may decide in your particular environment that you don't want Snyk to consider that run as non-root true to be a medium vulnerability because perhaps you've got some admission control, which means that you couldn't have a container running as root anyway in production. So you can control what priority score any of these things have. So if we go back here again, we can also see that I have Snyk code turned on in this repository, and Snyk code will actually analyze the code you've written yourself to look at where you might have introduced vulnerabilities. And we can see in this application we have a whole bunch of different things within our own code. So this is not the open source packages that we've imported, but things that we've actually written. And it's going to show me if I look at the details of this particular one, it's not only going to show me that I have this potential command injection vulnerability, but it's actually going to show how that moves through the particular piece of code. So we can see it stepping through the flow there, showing how that unsanitized input from the HTTP request, which is coming in at this line 80, will then flow through and then is passed into an exec without sanitizing it. So we could at some point get some malicious data into that HTTP body. And what Snyk code will also do is show me some ways that I might fix that. And Snyk code actually analyzes millions of lines of open source code that are available on the internet and looks how other people have fixed that. And we can see here we've got 3 potential examples of code which doesn't have that issue from 3 different open source projects. And so we have a range of options we might take as examples to see how we might go about fixing it. We've looked at the Snyk UI quickly. So I'm just aware that we may be getting on in time. Let's take a look at some of the container stuff from the UI perspective, and then we'll go and look at some of the things from the CLI. So when I want to import a particular container into Snyk, a container image that I want to scan, we have a range of integrations with pretty much all of the container registries. I've got this set up to integrate with Docker Hub, and in exactly the same way as I imported a project from GitHub, I can just add project from Docker Hub. This is going to look at my Docker Hub account here. I can select any of these containers and it will import that container image into Snyk and scan it on a regular basis. But I have some here already that I have been scanning. So we can see that I've got this container image that is in Docker Hub, and this has been scanned. It's got lots of vulnerabilities in it, and again, Snyk has suggested alternative base images that I might use in order to remediate some of those vulnerabilities. So I could take my vulnerability count down to 60 again by using Node Slim. What else do we want to look at here? I don't have anything with the Kubernetes integration set up at the minute, so let's go and look at some of the developer tooling now and see what that looks like from an integration perspective. So if we come back here again and let's look at VS Code. Let's just hopefully that is big enough. Let's just close some of these. So again, this is my example vulnerable application. And so if we go and look at the package.json here, which is the one that's defined where all of my dependencies are defined in here. And I'm actually running the Snyk vulncost plugin here, which is showing me straight away in my IDE what the vulnerabilities are in each of these packages. And so if I can hover over it, and straight away it's showing me I've got 4 vulnerabilities in that particular package. And if I click on quick fix here, I go fix vulns, and it's going to show me what those vulnerabilities are with the links to them from the Snyk's website, and tell me which version I want to upgrade to. So by upgrading this EJS to 3.1.6, I would fix all 4 of these vulnerabilities which are currently displaying here. And then if we go and look at some actual code here, we can see that we have our output from Snyk code here. So we see that unsanitized input from the HTTP request body that we just looked at in the UI is here again in my directly in my IDE. And if I go show this suggestion, that's going to open it here, and I can now get all that information that I was looking at in the UI directly in my IDE. So it's showing me what the flow is through that particular piece of code, and some examples of from other projects about how I might go about fixing that. So let's stop sharing there, and I'm going to now go to my CLI and just show you all the things. Let's make this a little bit bigger. So all that functionality again is available directly from my CLI. So if I am working on a particular piece of code, I don't need to change out of my environment in order to go and scan it. So for example, I can test my third-party modules directly from my CLI, and that's going to look in this repository. It's going to have discovered this package.json. And we can see all of those issues that we saw just now in the CLI, in the IDE, and in the UI directly here from my CLI. We've actually also got a wizard here which will let you fix things directly from the CLI, and there's the same way as we were kind of saying about making these things actionable. What the wizard will do is to go through each of these things in turn and say, do you want me to fix this, and automatically fix it in my in the package.json before I've even checked it in. So I'm not going to get into that right now, but what I can also do from here is I can test my container images. So let's have a look what I've got here. Right, so I can do Snyk container test, Matt Jarvis, Matt.net-node. And that's going to test that container image directly from a CLI. I've got it in my local Docker, so it's going to test that one. Although because it's I've got the full URL there, it's going to go off and test that from Docker Hub if it didn't exist in my local Docker. That's going to take a little minute to run. So why don't we, let's just open a new tab there while that is running. And then the last thing would be to look at Snyk code. So again, we can have access to all that stuff that Snyk code was showing us in our IDE, and in the UI is also available to us from the CLI. And then here we can see that our base image scanning has come back. Our container image has been scanned there. It's given us a big list of all the things that are vulnerable in that particular container image. And if I gave it the Docker file on the command line by that -- file equals the Docker file, that would actually give me that remediation advice that we see in the UI to tell me which base images I could potentially upgrade to. So at that point, I think I'll stop there, and we'll see whether we have any questions. Saim, anything you want me to cover in a bit more detail?
No, that's wonderful. Actually, that's
wonderful. Actually, that's wonderful. There's a wonderful explanation of all these kind of things, because one of the things that I see from the past, of the experience, that when the Docker came up in the tool being, and many are thinking about the Docker is just a one tool that gives all kind of things like Docker, Docker Swarm. So it's kind of these kind of things. There's the Kubernetes came into the being, and the Docker and Kubernetes are the separate things. So some of the people are really happy about what the Docker is doing, but some of the people are really angry that they have to learn now Kubernetes to manage and orchestrate these containers. So I'm really wishing that the Snyk is a single tool, the single place where all the things are happening there, because we know, as me and you, we are talking about these of the container things. They are very different, because running the container as a root, running the container as a container has an image vulnerabilities in it, then we're securing the cluster, the nodes with the Kubernetes worker running on, then the securing the connection between these nodes, and securing the connections between how the control planes work with the Kubernetes data. So there is so much in the unpack to be back. But we just see that the Snyk has some kind of the code fixes. That's wonderful. I think I want you to explain these a bit more, because the developer have written the code in the laptop, and now the suggestion is provided by the Snyk. These things you need to cater for in order to go about these, because that's a wonderful tool that Snyk has. I want you to elaborate on these points, why it is so vital to scan on the developer machines to think about the security.
Well, I mean, I think the response, because the developers are much more responsible for these things now. You know, when we look at something like Kubernetes YAML, you know, if we went back 10 years in time, right, and the person who managed virtual machine images or controlled the virtual network was not likely to be developers, right? So that's why it becomes much more important for developers to scan this stuff when they're creating it, is because of where the responsibility is. And, you know, the quicker we can fix these things, the easier it is in the long run, right? So if we can fix it right when the developer's working on that code by giving developers easy to use tools that enable them to make decisions about which things to fix first, but also give them the right information to make the fix, right? So they don't have to go off and investigate what that vulnerability is. They can just see that list and go, right, well, these ones are the ones that Snyk is suggesting to me that I fix. I can raise an automated fix PR against that, and then that job is done, right? So, and the cost of that in terms of you know, the impact on productivity and you know, the slowdown of anything is that's the least impactful place where we can fix things. So the more things we can fix when developers are working on that, the better, right? Because that stuff's then got nowhere near production.
Yes, absolutely. I think that the point to raise it, no, that's absolutely perfect to draw the analogy, because in the VM world, the developer is not thinking about the virtual machines they are managing. There's a platform engineer, the system administration engineer, they are managing it. But in the Docker and the Kubernetes and in the container worlds, developers are actually who written the code. They are now building the container out of the images. So this has his responsibility to secure that image that is deployed
and not just building the container image, but building the configuration for that container image in production as well, right? I.e., they're writing the deployment YAML for Kubernetes. So, you know, they're basically configuring the infrastructure at the same time.
Yes, absolutely. Because we are writing the configuration files in the Docker file, and Docker file contain all the dependencies and the application configuration data backed into it. So that's the number one way of developing these tools. Another common question I've seen from the community coming up, we have tools like CRI-O, OPA, Gatekeeper. These are the tools exist there. These are the rules are enforces the policies. How you think the Snyk fit into this picture of policies? Let's say you want somebody else to not to run the container as a root. So how these tools are different from the Snyk, or Snyk utilizing these tools? What are the roadmap in the future for the Snyk to integrate these tools into the Snyk? Because I want the Snyk to be a one place, one shop for managing all these kind of things.
Yeah, so I mean, I think they're complementary, right? Because Snyk allows you to catch things that earlier in the pipeline than you know, Gatekeeper stopping you from deploying in production. But ultimately, like I said in the talk, you know, to have full coverage of what of really being sure that your deployment pipelines are secure, then you want to be using compliance type tooling as well as scanning in your development pipeline. I mean, Snyk behind the scenes, the Snyk's infrastructure as code scanning is actually using Rego, which is the language that Open Policy Engine uses, and so we definitely see there being over time a kind of closer integrations with things like that, whether we have an admission controller ourselves or whether we integrate with things like Gatekeeper. But we definitely see that as being part of the puzzle as well, right? That the sort of compliance testing before you get to production.
Yes, also, and on top of that, because we are discussing about the OPA, the gatekeeper, one of the new tool I think is came into the market that's called Kyverno, and people are already talking about, because Kyverno is not introducing the CRDs like the OPA gatekeeper does. They have built on the CRDs, and that these CRDs are enforcing the policies. But in the
Yeah,
Kyverno is you have not integrating the CRDs. They are the Kubernetes native, and they understand the Kubernetes hierarchy. Like say the pod is encapsulated in the deployment in the replica set, and the
yeah,
inside the
yeah.
pod is happening there. So it's mean the deployment is failed right now. So what's your tool? What you think about this Kyverno and the OPA? Because these are the two tools that's doing wonderful
Yeah, I
things.
mean, I haven't used Caverno, but I am aware of it. And you know, Caverno's big thing really is about being kind of native Kubernetes, right? In the sense that the policies are stored as CRDs in the Kubernetes cluster, right? So I think if you talk to the Open Policy Engine folks, they would say that I think that that Open Policy Engine actually has a wider purview than just being about Kubernetes, right? The idea behind OPA actually to start with is to be a general purpose policy engine. Gatekeeper and Kubernetes is just one part of what that tries to do. So I don't think those two things, they obviously exist in a very similar space. I mean, it's going to depend which is the better fit for you, for your environment. Perhaps you're using OPA for other policy related things within your environment. And so therefore it makes sense to hold all your policy things there. If you know, want everything to be natively in the Kubernetes cluster, then obviously Caverno is going to be a good fit for you. But I think that's a nice thing about the CNCF landscape, right? Is yes, there's a lot of tools, but gives you a lot of choice and flexibility about which things are going to be right for you.
Yes, definitely. So I think we have 10 minutes left, so I will utilize this best time because I have this opportunity to talk to the person who have 2 decades of experience of building up these tools and implementing these tools. So next thing coming up in the mind, another tools like the container runtime security. The production environment, the containers are running, and you want to trace the system calls happening inside the container. So where the tools I think fit into the Falco security are building these kind of tools.
Yeah.
So let's say somebody is using the Snyk. Do they have these leverages to have a container runtime security, or it's now they have another tool they are using the Snyk for the dev workflow, container imaging vulnerabilities, and other kind of stuff. And now when they move to the production, they are bound to use a Falco security as a runtime security.
I mean, again, I think they're complementary technologies, right? I mean, you know, Snyk doesn't do anything directly in that runtime anomaly detection space. I think Falco is a super interesting project. You know, runtime anomaly detection is still a very emerging technology space. You know, it's complicated. It generates a lot of noise, and you need to be able to understand the noise. And so, you know, when you see adoption of particular pieces of tooling, I mean, even things like OPA and Gatekeeper and stuff are still pretty small, you know, in terms of adoption, widespread adoption. And I think runtime anomaly detection is probably even smaller because it's such a new technology space. But you know, I think eBPF that's based on is super interesting technology. And I think, you know, we're going to get into a world where we start to be able to link these tools up more and more, you know, because that's really what we are interested in, is how do all these things work together. And I think we get much greater insight in being able to say, well, you know, yes, this container has this vulnerability, but can we actually exploit it in our environment in production, right? So is that container have the right network port exposed? Does it have a direct network service that goes all the way from A to B? You know, and I think we'll get to the point where we can start to really link these things up and be able to prioritize much better on which things we should fix based on the real world of how is that application deployed.
Yes, definitely. And another question that's really confusing for a lot of the folks and interesting one. We had the vulnerabilities are shown in the dashboard, and let's say somebody is using the Node 4.6 image, and they're seeing the 3000s of vulnerabilities came up. Then they goes to the Node Slim version, and the vulnerabilities goes down to the 300 to 60. But let's say that the people are talking about this concept. Let's say the Node 4.6 image that has 3000 vulnerabilities. It's a better written code as compared to the Node Sling that has 60 vulnerabilities. So it's a concept that what's happening there. Let's say if that scenario came up, the vulnerabilities has go down, but the newer image has a very bad written code, not a logic backed in. So do we see some kind of standards around the cores and the security and the vulnerabilities? We see the CIS benchmarks, but I think it's for the developer, let's say they're written out. It's a very complicated concept, it's very confusing, but people are talking about these kind of things. So how you counter these kind of comments where people are talking about these things?
Well, I mean, if I think I'm understanding what you're saying correctly about, so I think the question was about slim images versus the larger runtime images, right?
Yes, definitely. One question is the slim images that are you using as compared to the larger images. So the larger.
Yeah. So I mean, I think, you know, I mean, I just did a talk at DockerCon, and I'm going to be talking at KubeCon about exactly this space about how do I go about managing base image vulnerabilities, right? Because we don't treat base image vulnerabilities in the same way that, you know, we might fix things in a virtual machine. We're not going to start upgrading packages. But, you know, those full runtime images where they're, you know, they're by default, they have everything in them because they have to be so generic. They've got to run every node application, right? So they're always going to have more vulnerabilities in them. It's not that they're bad code. It's just they've got a lot of stuff in them. I mean, a lot of them are very big as well, right? I mean, I think some of that comes down to understanding how to do multi-stage builds properly. So, you know, really what we want to do from a best practice perspective is to deploy to production in a slim image, and whether it's Node or Python or whatever, but slim, you know, where we've got a minimum attack surface. So we want almost nothing in there apart from what's required to run our application. But those bigger generic images are useful when we want to build things. So, you know, in a multi-stage build, we might start with when we build our application, we use the bigger image, and then we take that built application, take that artifact out using a multi-stage build in Docker, and then we put it into a slim one for deployment. I think the problems happen really when people take they perhaps don't understand that, you know, how to do that, and then they end up using those big generic images for production deployment, which is just, you know, it's the wrong thing to do really, and you're always going to struggle to control how vulnerable those things are, because they've got to be generic and they've got to fit everyone's use case. I think it's also important for people to realize that you're almost never going to have a container image that has 0 vulnerabilities, right? And so, I mean, unless you use Scratch, where you've literally got nothing else in it, you know, you just 0 shouldn't. I don't think is a realistic expectation. Like I say, if you go and look at my DockerCon talk, which is online, you can see some of the things that I talk about in that talk about how to think about container image vulnerabilities and how to come up with strategies for you know, for good practice overall.
Yes, definitely. I've seen that talk, and from that, it's a basic ground for me to learn the DockerCon you did it. So I put the link for the YouTube listener who are listening to us.
Great.
So if we have just 5 more minutes. So let's talk about, we're talking about the container security and these kind of things. So let's try to explain how the Kubernetes security is coming to being. So Kubernetes have, I think, four objects in the control plane, like Kube API server, controller manager, scheduler, etcd, then the worker node has kubelet, kubeproxy, container runtime. So there is so much into the Kubernetes. And ever since your adoption of the Kubernetes plus the distros came into being, how the Kubernetes security is challenging for the companies and the wider ecosystem?
I mean, I think, Kubernetes is a massively flexible platform, right? And it doesn't give you guardrails. So, a lot of the things that some folks say, oh, well, Kubernetes is insecure by default, but that's a feature, not a bug, right? Because it gives you the choice of how you implement those things. And so, yes, by default, lots of things, if you just go and deploy an upstream cluster, it's not going to stop you from doing things that are probably a bad idea, right? I mean, you can do a deployment with no resource limit set, and straight away somebody can denial of service against that kubelet. There are lots of things, service tokens auto-mounted in pods blocked by default. In terms of the security to properly secure a Kubernetes cluster. Clearly, there are other things, right? I mean, there are opinionated deployments of Kubernetes by lots of vendors. There are things like OpenShift, which is much more secure than upstream by default, and on a lot of those things by default. So I think it depends on your viewpoint, really. I mean, a lot of people are probably better off taking an opinionated service from a vendor. Is your business in having to worry about all these things? And most people's business is about worrying about Kubernetes security, right? Kubernetes is supposed to be a tool for you to do something else, deploy an application, provide a service, whatever it is that you're. So the more time that you spend in engineering having to deal with things of that function, that's basically lost hours to you. So, I argument these days for saying, managed service for some things, because it's probably not going to be, either you're going to waste lots of time on having to worry about these things, or it's going to be expensive for you, or you're going to have a disaster.
Yes, definitely. I think I think everybody who is listening to us is a Matt Jarvis is a person for you on Twitter to follow up if you want to learn Kubernetes security, Docker and container security. So I learned so many great. Every time I talk to Matt Jarvis, I learn so many great amount of session. So Matt, final thoughts before I let you go. Somebody who will watch this session, what are the next steps you could take? And on the topic of Kubernetes, what are your points? What are the basic things they need to cater for in terms of security?
I'm sorry, I lost you for a second there. Can you the question?
Okay, so I can repeat. So the last few steps, if somebody are listening to us on this YouTube and they are watch your session, what are the next steps he would take in order to build up the ground up for the security? Plus, if they are using
I would highly recommend for involved with the tag security, the CNCF tag security group. It's a super friendly bunch of folks, and some outputs that have come out of that group. The CNCF security white paper, a really detailed, fantastic overview of all of the issues that you might want to be thinking about in terms of cloud native. Like with all of these things in our community involved, even if you're a beginner, all of the working groups and the special interest groups and super friendly. So turn up for some meetings, lurk in the background, have a listen to what people are saying, and get involved.
So thank you very much, Jarvis. It's a Matt Jarvis wonderful session. I learned a lot of cool things about you, and every time I speak to you, there is so many great things I have learned. So thank you very much. Hope to see you in the future webinars as well, because we are living in a world where our wonderful industrial and IT legends available for us to be hang out with us. and sharing knowledge with us. So Matt, thank you very much. Hope everybody who are listening to us and watching them from YouTube, Snyk is a tool for you to be most things about the security of containers and Kubernetes. And if you want somebody else topic, let me know on the YouTube comment. We can contact again with Matt Jarvis, and we will do another session on your request in the future webinars. So Matt, thank you very much. Hope to see you again in the future. And bye bye, Matt.
Bye.